this is Ananya, and last time we finished with linear search in Python, and now, as I had mentioned, we will be seeing a better search algorithm, and here we are with binary search. Now, why is binary search better than linear search? We'll be looking at that through the algorithm and the pictorial presentations also. So let's get started. Now let's say you have an array pretty similar to the one we had during linear search. Now while I'm drawing this, what I want you to do is try and figure out a pattern, alright? I'm going to have, let's say, 6 numbers, or 7, 8, 9. Okay? I've got 9 numbers and I want you to figure out a pattern from it. Now start. I've already started. You got to start thinking now. It's pretty simple, you know, you'll be able to do it. You noticing something? Anything coming in your head? And I'm done. Are you done too? Well, if you got it right, this is in the ascending order. You see everything going from small to the biggest. And that is the main difference between linear search and binary search. So in linear search, the array does not have to be sorted at all, whereas in binary search, it has got to be sorted. Now, let's move on to the actual algorithm. Just like the previous one, let's put positions for each of them. That there's 0, 1, 2, 3, 4, 5, 6, 7, and 8. Now, if you can notice, can you find the middle element from here? And obviously, the position 4 containing number 42 is the middle element of this array. And you have an even, let's say, okay, let me take some other color. Okay, you have an even distribution here, and hence this is going to be 2 partitions that you made. Now, next what we have to do is, after finding the middle element, obviously you need to have your key. That is, let's say our key value is, let's take 61. All right, anything random, whatever the user wants. Now what binary search does is, it checks the key with the middle element, that is 42 in this case. If key is greater than 42, it'll only check the right side, CR, check the right side, and if the key is less than 42, it will only check the left side, okay? Check the left side. And hence, you only perform any one of them, not both. And hence, you see the time gets cut down into half. So now you get to understand how linear search is not that good in terms of time complexity, though it is simple. But binary search is way ahead in terms of time complexity, because obviously you're checking only half of it, right? And that's basically it, you know, just a quick run through. We'll be seeing this in detail when we are solving it, you know, coding it rather. So you have a key, you have an array, you have your middle element. Also, it's pretty simple to find the middle element. Your basic formula will be low, that is, let's say left, the left element, that is 0th position, plus the maximum element that you have at position 8, that is, you take the positions, okay, not the element. So in case this is right, minus the left position, and you divide this by 2. Please make note of this. You have to floor divide it because you don't have, you know, any option of using decimal points. Hence, you need to use floor division. This will basically give you the middle element, and it's pretty simple. It ends at that. Now, let me just get this out. And where were we? Middle element found, key done, array is ready. Now, we'll check 61 and 42. And now, since 61 is greater than 42, it will only check the right side, nothing else. All right. Pretty simple, right? And then what it does, it imagines a new array, okay? You form a new array consisting of the numbers. Let me write it down here. 56, 61, 75, and 81. Okay. Now, this new array is again performed all of these operations. So again, you find a middle element, which in this case will be 61. And now that if you can notice, the middle element and the key match. Okay, key is equal to M, and hence our binary search is done. That's pretty simple, right? And that's basically it. We are done with the algo. We've imagined it, and now we are all ready to start with coding. All right, now just a quick recap. Most important part, it has to be sorted. Okay, it needs to be sorted. And here is a quick run through. Sticky note, go in place. Okay, I like to have a little bit of color, you know. Okay, so okay, that should be good. Now you find the middle element. Next, if the key and the middle element matches, then you break it and return the element. That's it. Otherwise, you compare them and select either the left half or the right half of the array, and that's it. Then you loop through it till you find the middle element and the key matching, and that's it. Let's get started with coding. And we're back with the code now. So inside the array, let me just put in random numbers, but which are in a sorted manner, right? So let's take 12, 23, 45, 56, 78, 79, and 101. Okay, so how many elements are these? So it's 3. Okay, let's take an even numbered array this time. So what are we left with? Okay, 200. Now if you can see, let me just enlarge in this. The left half, that is up to 56, and there's this right half that is 78 to 200. How are you going to choose the middle element now? Remember the equation that we had gone through? Lower, that is 0, plus the maximum one, that is what position is 200 at? 0, 1, 2, 3, 4, 5, 6, 7, right? So 0, let's come here, 0 and 7 minus 0, which gives 7. 7 divided by 2, that is a floor division, is going to give you 3. So 0, 1, 2, 3, number 56 at the third position is your middle element. All right, now this being done, let's take our key as, let's say, 101. It is present, right? So we want it to be the correct answer, that is this print result. Now again, just like our linear search, let's go back and to a function named binary, and similarly we are passing the array. Now note what each parameter means. First is the array itself. Next is your starting index, that is obviously 0. Now your length of the array. Now if you notice, you might not always know what the entire length of the array is, right? That's quite not possible if you're taking user inputs. And hence, the logical thing to do is just using the length function, you take the entire length and subtract it by 1. Now why subtracted by 1? That's something that you need to know by now. And lastly, we pass the key. And now we take these variables right up to these variables named array, lower, that is all, let's take it as left and right, and the key. Now you need to run it inside a loop as usual, because you have to iterate at least a certain amount. So while the left position or value is less than the right position, what you do is you calculate the mid value. We already know this by now. And as I had mentioned previously, remember numbers such as 19 that were turning out to be the middle element itself. So if array of mid is exactly equal to key, then return the mid value. Else, there's another condition possible. If the array of mid is less than key, then what do you do? Let's say our middle element is 56 and what we need to find is 101. So if 56 is less than 101, is that the case? Yes, it is. So next you pass your lower element as mid plus 1. Now what is mid plus 1? That is the position here. That's 0, 1, 2, 3 and 4. So L now becomes 4. So now the array it looks into is only this half. That is 4, 5, 6 and 7. That's it. And
Hence, you again start from the while loop, calculate the mid value. Now, what will you get it here? You'll probably get it as 79, I guess. 79 will be your mid value if I'm not wrong. And that's it. This entire thing goes on. And what if, just in case, we were to find the number 23? That would be less than 56, right? And hence, this else block would be executed. Hence, the highest value, that is lower value, remains the same, right? We are not changing that. So from left, from 0 up to this value, that is 45. 12, 23 and 45. Okay, you got that, and I really hope you got this. In case you didn't, just pause the video, try it out by yourself, or just look at it again. I'm sure you'll get it. And lastly, what if it's not present at all? Obviously, we return -1, just like we did in linear search, and hence you print all your results here. Just a quick run, and there you go. You have element is present at index 6. Pretty nice. Let's make it 23. And let's run that again. And there you have 23 is present at index 1. Alright, I hope you all got it. I'll see you all next time with another video. Bye-bye. See you soon.